Alright, so as I said, the compal, this is a compal PCH, so I finished ICH. We did the timing from the timing diagram, and we looked at the power up sequence and the hard start for the ICH using the Inventec and the Toshiba C650. So this class we're going to do compal, which is a PCH based board, which is the Intel Series 5 first generation. This is the first generation of the Intel Series i3, i5 and i7, right? We're not going to do PCH in depth. We're going to do the history of ICH and PCH and what are some of the new implementation that is implemented, which is carried over from the predecessor, which is ICH Intel Series 9, right? And how and the new features that has been implemented inside of Intel Series 5 chipset, first generation, second and third generation, up to the fourth generation. And then we're going to do Intel Series 6. Intel Series 6 chipset and above is this, the timings is the same. So we're just going to do 6 and stop there. As 8 and 9, Intel Series 8 and Intel Series 9 will have the same timing, along with the Haswell and the Broadwell core chip, single core chip, all have the same timing. So but in this class we're going to do the protection and isolation circuit. As I said before, the compal has 3 different types of input isolation. So we're going to look at the first one, which is this one. I won't get the chance to teach the other 2, but hopefully one day. Right, so we're going to go to the input isolation circuit, and that's let's go to page say 34. Good, we are there. Good, this is it, page 34. Alright, so this is the input isolation protection circuit. This is where this is the DC jack, right? JP J1, JP PJ P1, sorry, right? So pin number, so this is when you plug in the charger, right? As you can see, pin number 1, 2, 3, 4 and 5, right? Pin number 1, see we have pin number 2, which is the ADP signal. This is going to the IO controller. We're going to reach when we adapter insertion test signal. If the center pin in the charger is not working, no light will come at the DC jack. Remember, HPs have, when you plug in the charger, you see that white light at the DC jack. You won't see that white light at the DC jack if the signal is not coming from the input signal of the adapter, right? The adapter ID, this is a software that is embedded in an EEPROM chip inside of the charger, just like the Dells, right? So if the signal is not coming, so the ProBook, HP ProBook needs this signal, right? No trigger fall. You have standby voltage but no adapter signal. So this DV4 needs this signal in order for it to trigger as the adapter insertion signal, right? So this one is a different one where we need the center pin, right? So pin number 3 or 4 grounded. Pin number 5 is for the turn on this P channel MOSFET, right? This is a P channel, right? So when this voltage comes from the adapter, right, it comes to here, right? And this is a P channel. This signal will come only after the signal is present, as you can see, right? When the IO controller, see page 31 is the IO controller, right? KT connect to KBC pin 97. So the IO controller release this signal only if this condition is met. If this signal is not coming to the IO controller, it won't release the AC LED low to conduct this transistor, and it will conduct, and this will become 3 volt, right? 3 volt always. That's why when you plug in the charger, before you press any button or anything, the light come at the side. That is coming from SMPS, plus 3 volt always, as you can see, right? If any fault in this transistor, not trigger fault will come, right? If any fault with this transistor, not trigger fault will come, hence no AC LED will come, right? So the EC, or the embedded controller inside of the ion controller, is controlling the light at the DC jack only when ADP ID underscore ID is present. This is about 12 voltage, right? It goes through a conversion circuit and becomes 3.3 voltage, which we're going to look at shortly, right? So pin number 1 is the main supply. This is a OR diode, or you can call it a AND diode, but you can call it a OR diode any way you want to call it. This will become AD pin, comes through these 2 decoupling capacitor through this coil PL1 to produce what? V in, right? This is V in, and then to another card, it becomes dock V in, right? This dock V in, it has a docking station, right? If you notice, there is a slot right on the board, but this is not really used, so this is not really necessary at the moment. All right, so this V in, this is the main, this is from adapter. Anytime you see the signal, it is only coming from the adapter only. V in is only from adapter, so it comes through this or diode PD1 through this decoupling capacitor through PL1 to produce V in, right? Let me zoom out, right? This is only from battery. This is in battery mode, BATT, right? But we're not going to look at that as yet, right? This is, see, this is the battery connector, PJ-P2, and this is PJ-P1, right? We won't look at the battery section as yet. Alright, so let's go to the next page. So let's go to the next page, so what they have for me. Alright, so see, V in, the same V in is coming from the charger, right? Which is coming from charger from here, which is generated. V in comes through this MOSFET, right? Let me zoom in, sorry. V in comes to PQ101. This is a P channel MOSFET, as you can see arrow on the outside, right? This is a P channel MOSFET. So in electronics, we know that P channel MOSFET only conducts where the voltage at the gate is less than the voltage at the source, or where the gate is negative, right? If the voltage at the gate is negative, then it will conduct and produce P2, right? But this MOSFET only will conduct only if PAC is high, right? PAC must be high. PAC must be high in order for this to conduct. So if the PAC comes through this resistor 3 kilo ohm to this NL channel MOSFET, this is a 2-in-1 MOSFET. See, we have B and we have A. So we have PQ109A and PQ109B. So this is a 6-leg MOSFET. See, 1, 2, 3, 4, 5, and 6. Right? This is a 6-leg. In physical appearance, it is a 6-leg MOSFET. Right? Physical appearance is a 6-leg MOSFET. So in PAC of height, this PAC in is about 4.5 volts. Come to this resistor of 3 kilo ohms. The ground will shift. The ground will shift over here. PR109, PR109, and PR206. Look, PR109. When the ground shift over here, PR109 is 150 kilo ohm, and PR106 is 200 kilo ohm. It will become a voltage divider automatically. The voltage here is about 6 voltage, right? This will be about 6 voltage. So let's calculate it. Let's calculate the hysteresis value of this P channel of this MOSFET. So we have PR109, which is 150 kilo. So the V in, so the voltage of PAC in, voltage of is 19 volt, right? So we have 19 volt coming, right? 150 kilo ohm, and this one is 200 kilo ohms. Let's calculate. 8.14, beautiful. So the voltage at the gate, is less than the voltage at the drain. This is a P channel MOSFET. So this is coming from drain to source. Remember, drain to source. So the voltage at the gate must be less than 18 voltage, right? And I'm going to calculate the value of the in compal. The voltage must not be less than 15.62 voltage. The voltage at coming from V in to P2 must not be less than 15.62 voltage. So from rising edge, the rising edge voltage is 17.09 voltage. And I'm going to calculate that